Hola, mi clase. I was told to speak Spanish. Start my videos out better. So 3.5 scatter plots and the line of best fit. So we're going to create what's called a scatter plot today, and then also talk about what is a line of best fit. So a negative association of a scatter plot is when the y values tend to decrease as the x values increase. It just means that it's looking like it's going down from left to right in general. And then we would call that a negative correlation, meaning their relationship or their association is negative, right? Association, kind of like I associate with that person, I have some kind of relationship with that person. So if we have a negative association, it means there is a relationship, it's just going in a negative direction. And then we call it a negative correlation. So then we have what's called a no correlation. It just means that the relationship between the x's and the y's have nothing going on. They're all over the place. They got nothing to do with each other, okay? And we won't be able to make any predictions or anything. And then a positive association is when the y values tend to increase as the x values increase. So that's our positive direction, just like a positive line. And we would call it a positive correlation. So when the data has a positive association. So if it has a negative association and a positive association, we can draw what's called a trend line. And it models the data by showing the direction of the data. Can be used then to make predictions. It also sometimes referred to, and I think there's supposed to be 2 R's in there, but that's okay, as the line of best fit, as you can see at the top. So trend line or line of best fit is the same thing because it's the best line that shows the trend of the line. Okay, it'll make more sense when you see the scatter plots and why we would need to do this. So these are what we call scatter plots. This is how data is taken, right? We take lots and lots of data and then we try to use that data to make a prediction. Either on a data point that we haven't found or for later use. This is similar to when you go see the doctor, especially when you were younger, and they would say, oh, your height and weight, are in this percentile. It has to do with all the data they've taken of children. It doesn't make it wrong or right. It just means, hey, this is kind of where we should see this. If we're not seeing that, there might be an issue. Okay? So for right now, we're just going to determine what their relationships are. So it says, what is the relationship between the hours after sunrise? So they got that from right here. And the temperature. So this is the time that the sun has risen, 10 hours after, and then what the temperature is doing while the sun rises. So remember, we have negative, positive, and none. Okay? So if we look at the general direction of this, the x's are increasing while the y's are increasing, right? These are our smallest for both, and these are our highest for both. So we would call this a positive correlation because it has a positive association. So the next one says, what is the relationship between the hours after sunset and the temperature? So this is completely opposite, right? Now the sun has gone down and it's 10 hours after. What has the temperature done? Well, again, if we look at it now, the y's are decreasing, the y's are getting smaller as the x's are increasing. So we would call this a negative correlation. Figure I'd type relation, make it easier for you to read. Okay, because that's what the definition is. Y's decrease while x's increase. And then this last one is the relationship between hours after sunset and the amount of rain. So again, this is the sun has gone down, sunset, and this is how much time has passed, and this is how much it's rained during that time. Now, because the data is all over the place, I cannot make a prediction. We would say that this is a no correlation because I can't make a prediction, and basically what it's saying is that when the sun goes down, it has nothing to do with it raining. Where if the sun comes up, we know that the temperature is going to rise because there is a relationship between the sun and our temperature. And vice versa, when the sun sets, we know that there's a relationship of the sun going away and what the temperature does outside. All right, so now it says, how can the relationship between the hours after sunset and the temperature be modeled? So this is where they're asking us to actually have a model of the line of best fit. So the line of best fit, or the trend line, is drawn and used so that we can then make predictions. And we could even use it to make predictions any day. Okay, it is Tuesday, the sun rose 6 hours ago, what would the temperature be? That's the point of the line of best fit, or the trend line. So what we want to do with this line of best fit, this trend line, is to get as many points as we can of the graph. And we want to then also try to get as many points to keep it even on one side and the other. So if I have, you know, about 6 on one side, I want to try to have close to 6 on the other side, and vice versa. Now, it doesn't always happen, it doesn't always work. So you can see I'm kind of adjusting this, trying to get as many points as I can, as close to my line as I can, but I also want to make sure that it's an even amount. So maybe about right there. So you can see I have 1, 2, 3, 4, and I have 1, 2, 3, 4. So I'm at a pretty good spot. You can even maybe consider these, but they're almost on that line, right? I could even maybe tuck it down a little bit more here. There we go. And so that would be considered our line of best fit. Even though here we see that it doesn't fit, but it's just for prediction purposes. It is not an exact answer. It's just the best option for the data. All right, so here's our other one, which was hours of sunset against the temperature. So now the sun's gone down. Why don't you try to draw a line of best fit in there? You may need to draw a race, a little, go slow, maybe get a ruler, kind of edge it out, and try to do it the best you can. You could saw that even with me using a line tool, I still was making adjustments. So pause here and make sure you do that. All right, so I'd say if you got anywhere, you know, kind of close to that, you could always even go through that y-intercept if you want. It would just mean that you need to adjust more. I don't really like that because it doesn't hit a lot of my dots, so I probably want to adjust so I can try to hit more of my data points. So as long as you're close to something like that, you're probably good. Okay, I try to hit as many of my dots I could. I'm trying to keep it even so that the same amount of dots are on one side as they are the other. And there we go. So just check, see if it's kind of close to mine. It doesn't have to be exact. All right, so for these 2 questions, it just wants you to decide if what these associations are, what is their correlation, positive, negative, or none. So I'm actually going to have you do these. You don't have to draw a line of best fit. It's just what is their association? Is it positive, negative, or none? So you answer question number 1 and 2, pause for a second, give yourself a second to answer those, and then move on when you are ready. Okay, so we are going to describe the type of correlation for each scatter plot. We are going to draw a line of best fit for our scatter plots, and then now we're going to actually find the equation for our line of best fit, or our trend line, so that we can then answer questions 5 and 6 below to make our predictions. So first thing to do here is to decide what kind of correlation this would be. Well, if I look at the first one, hopefully we all agree, we would call this a positive, I'm just going to go positive correlation. See how it goes up from left to right. Also, the X's and the Y's are getting larger as we go. So now that we've decided it's positive, we need to draw that line of best fit. Now, this little crooked line right here, you guys, is showing that the graph is jumping to a higher number from 0 that's not an even interval. So if you notice, from 0 to 50, and then it goes 5, 10, 15, 20. So this is just showing that they jumped from 0 to 50, which is not an even interval, and then started their graph. Okay, so we have to keep that in mind when we're looking at our equation. So I'm going to draw my line of best fit. Again, we always want to try to get as many points as we can. We want to cross as many points as we can. And we want them to be as even as possible. So I think that's a pretty good prediction. I'm crossing 2 for sure. I have 1 here and 2 slightly underneath. It's pretty even. So that would probably be a good line of best fit. Okay. All right. Now that we have our line of best fit, what we're going to do is find the slope and the y-intercept. So 2 ways we can find the slope. We can actually just use the graph and draw our triangles, right? I can count from here to here. So remember, this goes by 5. So 5, 10, 15, 20, 25, 30, 35. It went up, so it's positive. And then I would count this direction. And what you have to be really careful is with this one, they also went by halvesies. So this is really 1, this is a half, 1, half, 2, half, 3, half, 4, half, 5. So you got to be really careful with that. So if that's too tricky for you and you don't want to keep track of that, just use your points. So we have 1 point at 150, and we have another point at 685. And you can then do the subtraction to then find your slope. If you have it, if you think it's a little tricky to try to remember 5, 10, 15, 20, and then halvesies. Okay, so this will be a little more accurate if you're worried about that. But if you notice, I still get 35 over 5. And then we're going to reduce it as far down as we can, and we get 7. So remember, this is our slope. This is our m. And then we need to find our y-intercept. So you can do it 2 ways. You can use point-slope form, or you can use slope-intercept form. I prefer slope-intercept form since I'm going to use slope-intercept form in the end. So I'm going to use my first point here, 150. As we've said many times, I like smaller numbers. So the smaller numbers I can use, the better. So I'm going to go 50 equals 7 times 1 plus b. So the 50 came from my y, the 7 came from my slope, and the 1 came from my x. So we're going to get 50 equals 7 plus b. I'm going to subtract 7, and we're going to get 43 equals b. And then we have our equation now, y equals 7x plus 43. Now, before I move on to number 4, I'm actually going to drop down to question 5, and that's because it says for the trend line in item 3. So I want to stay together. This is item 3, so question number 5 goes to item 3. What would you expect the temperature to be after 2 hours? Explain what this means in the context of the data. So now what we're going to do is use our line of best fit to determine what maybe it is at 2 hours. There's a couple of ways you can do this. We can look at the graph and try to estimate it the best we can. That's kind of hard. We can actually use our equation. We know it's at 2 hours. We know the x is 2. So you actually could plug it in and go y equals 7 times 2 plus 43. All right, we can figure that out. So we get 14 plus 43, and we would say it's 57 degrees. Okay, so that's another way. And the last way you could do it is using your slope. We know that our slope is rising 7 and running 1. Well, we know that our point 150 is right next to 2. So if we, in a sense, what we do is we just take our point and add it to rise and then run. It's a positive. So I would do 50 plus my 7 and my 1 plus my 1, and it gets me 57 still. So there's a couple of different ways you could do it, okay? You can use your slope, you can use the actual equation, you can estimate. Estimating is probably your worst option. It's probably best to do something more concrete like the equation or using your slope. So then it says, explain what does this mean in the context of the data. It's that the temperature rises 7 degrees each hour. And that makes sense, from 50 to 57. It's an estimate, right? We don't know for sure. It's always not perfect, as we can tell our dots, but it's close. All right, let's go to number 4. So first thing we have to do is decide, is it positive or negative? So is the data generally going up, or is it generally going down, or is it neither? Okay, so we would hopefully say that this is a negative correlation. I'm trying to keep space here, so that's why I don't want to get it confused with the other one. Maybe I'll stick it here. This is a negative correlation. There we go. So if we have a negative correlation, we know that our line of best fit is going to go down from left to right. I'd say that's a pretty good line of best fit. It's hitting almost all of my dots, and I only have one randomly floating. So that's actually a pretty good line of best fit. We would almost consider this like kind of like an outlier. Okay, so why don't you try to find the equation now? I'll give you a hint. Go ahead and use this point and this point. We'll all use the same points. Okay, remember this is meaning they jumped by a different amount. Okay, so see if you can find the slope and the y-intercept. See if you can find the equation of this. So pause. See if you can find it, and then we'll discuss what we got. All right, so this point right here is at 2.8. This one's at 8.2. So we should have taken 8, take away 2, and 2, take away 8. They should be opposite of each other. We get 6 and negative 6, and hopefully you said the slope was negative 1. So we're going to now use this. For me, at this point, I don't care which point I use because they're basically the same numbers. I'm going to use, I'm going to use 2.8 actually. So I'm going to go 8 equals negative 1 times 2 plus b. So again, I'm using this point up here. I get 8 equals negative 2 plus b. I'm going to add 2. I'm going to sneak it in there, add 2. And I'm going to get 10 equals b. And if we look at our line of best fit, it's getting there. Maybe it's not exact, but it does go up in that direction, okay? So we would say that our equation is y equals, we could either say negative 1x or negative x. I'm going to do negative x because that's how they're going to write it on a more common basis, so it's best for you guys to see it that way. Okay, so there's our equation. So that takes us to question number 6. For the trend line in item 4, what would you expect sales to be if the cost was set at $6.50? Explain what this means in the context of the data. So I'm actually not going to finish that problem. I'm going to have you guys finish it, and then we will see how it goes when we get back to class. Okay, so I'm going to leave this one blank, and we'll talk about it in class. So just a main thing to remember is that if we say the negative description that describes the direction of the relationship, this is not the same as no association. It really does mean negative. Okay, there are relationships that have negatives, like the sun going down and the temperature going down. Okay, if you're losing money but making product, that's going to be a negative association, right? So that's something else to think about too. So negative and none are not the same thing. Okay, so please make sure you know that. You'll notice there's no independent practice, so that's kind of also why I left a couple blank, just that way you had the couple to practice on your own, and that way we have something to discuss when we get back. All right, until next time.